Okay, so it's been a long time since we went over the how to bring in a digital elevation model and some of the parts of QGIS. So I was just going to go over those. Hopefully, be able to do this in 20 minutes. So you're going to open up QGIS, an untitled project, and then where I get my digital elevation models is from something called TNM download. So you're going to search for TNM download, not interactive, but download. The tricky part for you will be finding your location. Because I know the exact location of Spillman Farm, I can just zoom to it. I just type in Pullman, and because this is the whole US, and then I just scroll down and I zoomed to the location of Spillman. You probably know the relative location for your fields, and so this might work fine for you. You can type in the nearest town, and then you can find, roads or other defining landmarks, and then zoom in, and because these DEMs are pretty large. Okay, so then after you've found your area and you've kind of zoomed in on it, because we don't want to get DEMs for a large area, just for our main area, you're going to come over to and I already have the DEM. You won't see the DEM when you start looking. You're going to come over to the we're in the data sets right here, this little tab data sets, and there's all sorts of data sets you can get from TNM download, including high resolution imagery that is 1 meter to half a foot resolution, and this is provided by the National Aerial Imagery Program. I believe every year they fly it in the summer, so you can get some nice imagery for free through the TNM download too. Okay, what we're looking for is elevation. We're not going to work with LiDAR elevation. It takes too much processing. So we're going to use the 3-dep. So we're going to check that on. It opens the drop-down menu. There's a couple different products. 1 arc second is 30 meter resolution, which is way too coarse. Then we have 1/3, which is 10 meter. 1/9 is, there's not a lot of the 1/9. So if I say show, you can see that doesn't highlight anywhere. If I say 1 arc second, it highlights everywhere because we have 30 meter data for the whole US. But let's work with 1 meter data, hopefully. So if it highlights, if you click on show and you have the 1 meter data clicked on and it highlights it, that means you can get 1 meter resolution elevation data for your area. If you can't get 1 meter, let me zoom out. I bet you can get 1 meter for, yeah, well, the 1 meter coverage is pretty good. There you go. So, oh yeah, it looks like all of Washington has 1 meter data, so except for down here. So you should be fine for most areas getting 1 meter data. That's what you want to go with. That has that nice high. That means that in the raster, each pixel or cell is 1 meter by 1 meter, and inside that 1 meter squared area, there is 1 elevation value. So that's a lot better than 30 meters by 30 meters with 1 elevation value. It's just way too coarse and smoothed. Okay, so you can get 1 meter data. It's checked on right here. I'm gonna hide it. And I'm only interested in elevation, so I have my 1 meter data clicked, and then I go back up and I want to zoom back into Pullman because if I were to click on search products, it would return all of the 1 meter DEMs for this entire area right here, which would be it would be a lot. So that's why you want to zoom into your particular study area as closely as you can. Okay, so here I am. I'm going to zoom in, and then I'm going to say search products, and then it opens up my product tab. And there's 16. So if I were to zoom out and scroll over on footprint, it shows exactly where that particular file is covering. Okay, so you might, if you're zoomed out enough, you might have to scroll through, the results and see exactly which one covers your area. Okay, I happen to know it's the one that I've already downloaded. And interestingly, Spillman actually is both of these areas that I have. You see right here, I'll show the thumbnail. You can click on thumbnail. So in order to cover all of Spillman, I have to download this one and this one, which I've done. So you're going to click on download link. It's going to go into your downloads, of course, and I would suggest you move it into a file where you're going to store your GIS project, because the way the GIS software works is when you have a project and you have the layers, these are my downloaded DEMs. Hopefully I save them. Oh, why aren't they showing up? I'm not quite sure where they're not showing up here. There we go. It's just taking a while for it to draw. Okay. I'll show you how to bring in the DEMs. We'll actually start over again, and I'll show you how to do that. Or I'll just bring in more. So anyway, when you open up your new empty project, you're going to have an empty window, and when you save the project, you have to save any layers and the project in the same folder. Otherwise, when you open up the project again to work on it, you don't have the layers, say they're in your downloads, it will give you an error message saying that your data is in a different location. So move it out of the downloads into a folder on your wherever, okay? And then you're gonna go save as, and then you can save your project in that same folder, not downloads. Okay, so how do you bring your data in? You're going to go to, there's two ways. You can either go to Data Source Manager, just hover over it, or you can have your browser panel, which is like your file directory, and you can navigate. It's probably going to be in your downloads unless you moved it to another folder. You navigate to where it is. I think I still have it in downloads, those folders. So the problem with using the browser panels, it's going to give you all the folders, and ignore the fact that I have lots of stuff in my downloads. That's terrible. So I'm going to use Data Source Manager, and this is a raster. So I'm going to click on the raster data to bring in. And raster data is pixel data, like elevation or land cover. Vector data is point, line, or polygon. And we can work with that. I can explain that to you some more if you wanted to meet again, because you might have some vector data if you have field boundaries and plot boundaries that you wanted to lay over your raster data. And I can show you how to make those. Okay, so let's go browse, and then see when I browse in my downloads, now it shows me only those files that are GIS files. And so I know right away, here's my USGS 1 meter. This is the row in the path. And it was 2018. Yeah. So the name tells me kind of something about the data a little bit. So I pull these in. I would just say, click on one, and I'd say open, and then add, and you have to close this window, and then go back to layers, and I can see that it's added another one of those. I have a copy. I don't know which one of these is a copy, but I have two copies of, there we go, I have one of the data. So I'm gonna remove that one. So if you find that you have a large area and you need to join two rasters, which is what I had to do. This is kind of just a side note. This might not happen, but it usually happens for some reason. You will have to merge them. So you go up to raster, miscellaneous, merge, and you choose the rasters that you want to merge, like that. You just select them. And don't worry about the defaults. And then you can save it to your folder. You're going to save to file, and you can name it, whatever. DEM study area 1, whatever. Run it, and you'll get your merged. You see now I have them connected like that. Okay. Okay. So now that I've done that, I tend to remove the originals. I don't want to have too much going on there. You'll notice I have a Google satellite image behind it. I always like to do that to make sure that I'm in the right place and that my data is lining up. And the way you get those background images is through an extension or a plugin. So you're going to go to Plugins, Manage and Install. And you're going to do this twice you're going to need 2 plugins to do what you're going to do today. Quick Map Services, and it says Easy Base Maps. Okay, and you say Install. I want to get these base maps. And then the base maps will be located under Web, because these are all web-based services. And you won't have this many when you first open up your Quick Map Services. You have to go down to Settings, and more services, and get contributed pack, and save. Once you do that, basically what this does is it loads a bunch of URLs for different background maps. So I can say, you know, I wanna look at the OSM OpenStreetMap standard background. So now it's loaded it because it's very quick with that. Then I turn off the Google satellite, and now I have OpenStreetMap roads and things like that. And then, so you can load any background map you want. Just make sure you load it so you can kind of make sure you're in the right spot. The right spot depends, and your data lining up is something that you have to ensure because of the different coordinate reference systems that your data can come in with. Okay, you'll notice down here in the corner it says EPSIG 26911. That's my projection or my coordinate reference system for my project. It's also the coordinate reference system for this layer, EPSIG 26911. And that's a UTM zone, very specific projection for Eastern Washington, okay? There is a general projection that's based on latitude, longitude, and when you collect data with the GPS or with your phone, like points to make a polygon, it will be in WGS 84. If you bring in 1 arc-second digital elevation models, it will be in WGS 84. You can't measure area or calculate slope if you're in WGS 84. Okay, so how do you find out what projection you're in? Well, you click on your layer, you go to Properties, Source, and it will say, here's the coordinate reference system. You could drop down and change it, but that would be like me calling you a different name, yet you're still the same person. So in order to change your coordinate reference system, you have to run it through an equation that the software does for you. And there's an equation for every conversion. And that's called reprojecting or warping, and we can talk more about that. You have to reproject your data sets so they're all in the same coordinate reference system if you want to do any calculations or line things up, okay? Anyway, we can talk more about that. I just wanted you to know that if your data is misplaced or not lining up, it's possible that you either change the coordinate reference system by calling it something else, or QGIS is not correctly handling those layers. So that's why I always bring in that background map, and I always tell people you need to know the coordinate reference system of your layers. Okay, if you bring in 1 meter data from USGS, it's going to be in the coordinate reference system for the area. In this case, it comes in as 26911, which is a coordinate reference system I recommend. And the units are meters. Okay, so now that we have the elevation, and we can take a look at the elevation, it's between, well, I made it between 600 and 800, but actually, go over to styling. If I say min max, the elevation goes between 0 and 845. And the 0 is because there's some no data over here. Okay, so that's our range of elevations here. Also, there might, I don't know why there's a 0 point, but I'm assuming it's because of the no data here. Okay, so if I want to see this in more detail, I go cumulative count cut off the lowest and highest 2%, and it should live update. It should. Live update, is it not on? If live update's checked on, it should update these values to my lowest and highest 2%. I don't know why it's not doing it. Anyway, so you might have some issues with it not listening to you, but if you do, let me know and we can troubleshoot it. Usually what cumulative count cut would do, it would remove the lowest and highest 2%. We can look at the histogram of the data. I'm really kind of going on a limb right here. And you can see that most of the elevation lies between, 700 and 820. So it's okay to cut off those low values and those high values, that highest and lowest 2%. You'll get more definition that way. It doesn't actually change the numbers in here. Anyway, side note. Okay. So now that you have your elevation, and I have a field loaded in here to show you kind of what a field would look like. It's this is a Spillman field, and I've changed it to transparent so you can just see the boundaries. Let's turn this off, and you can see it's right here in Spillman. There you go, and I've labeled it. So now what we're gonna do is I know you're interested in knowing the slope, so we're going to calculate the slope from our merged DEM. All right, so I'm going to type in slope. I'm going to use this slope tool, not the DTM, not any of these fancier ones, just the plain old QGIS. This is the native QGIS tool. It has the least amount of settings to mess with. And so we're just going to run the simple QGIS. We're going to try anyway. So what layer do you want to use as your input? We're going to use the merge layer, and it's in a projection that has meters, not degrees. And we're not going to multiply the elevation by anything. And then you'll save that slope to a file, to that file that your project saved in. Okay? I don't actually want to do that. So then you're going to, if you don't save it, it'll just create a temporary file. And I'll show you what that looks like. And if you have any questions along the way about this, just send me an email and I will be better about getting back to you. I felt bad about not getting you that recording sooner. Okay. So here is our slope. And it is very, you can see a lot of features in here because this slope is based on 1 meter data. Okay. And as a check, you want to make sure it's between 0 and 90 because the slope values only go between 0 and 90. So if you're getting values of like 320 or values that aren't that are like whole numbers or integers, then something went wrong. Okay, so as a check, it should be between 0 and 90. So here's our slope map. It's in grayscale. We can go to the layer styling and we can change that for our slope layer. I think I did this for you, to single band pseudo color. And then we can see the slopes between 0 and 83, and 83 is the blue. Again, here, there's a lot of low slopes, believe it or not. So when you hit min max, we're going to do cumulative count cut and cut off some of those lowest and those highest. And then you can see a lot more detail on the changes of the slopes. And yes, you can see steeper slopes are on the sides right here, and these nice, you can see down the bottoms, the flats. You can see more of the topography when you cut off those, the two ends of lows and highs. Okay, and the reason the slope looks so detailed is, again, because the elevation data was very detailed. All right, so slope's interesting, but one of the ways of reading slope that I think you might be interested in also is to see the contour lines. So another product you might want to make is under extraction, raster extraction. You're going to extract the contour lines from the elevation data. So change this back to your merged elevation data. Don't worry about the band number. There's only one band. And then the interval between the contour lines, because there's not a lot of elevation change here, we're not like on a mountain, we could make it 5 meter, or we could make it 3 meters between each elevation line. Don't change any of these. That looks cool, but I've never done that before. Then you can save it. And then we're just going to run it. And my computer is really slow, so it shouldn't actually take this long. But, the 1 meter data does require more processing. Okay. So now we're going to close it. And those are pretty contour lines. We'll come over here and style them. If your layer styling panel isn't open, you click on these little paintbrushes and it opens your layer styling up as a panel. So the yellow lines are fine. I think black would be better. So there we go. And then you can even label them. See, I'm going to have my labels, single labels. And I'm going to use the field, the elevation field, not the FID. So I can see, okay, it's going down this way. It's going down this way. This is the peak. Yeah. So it's kind of easy. Easier to see which way we're going here. But remember, blue is steeper, not necessarily higher elevation, just steeper slope. Okay, so hopefully that's something you're interested in. So there's your elevation, your slope, your contours, and then we'll do two more things. We're going to do an aspect, which I think is could be helpful. I mean, the way this an aspect is the direction, the I guess cardinal direction that the steepest slope is facing. And this is 1 meter data, so making an aspect map out of this is going to be real messy. But it, I'll show you how to maybe interpret it. Okay, so aspect, we're going to calculate the aspect from the merged. I'm not going to multiply it. I'm not going to, you can save it. Hopefully it runs faster. So it's the direction, it's the slope direction. And it starts from north, which is 0, and it goes 0 to 360. 360 is north also. And it's going to be pretty messy. I'll show you why. So it looks a little weird, actually. Well, let's see. Okay, let's look at it with some color to it. And you can see the values are between 0 and 360, which is what we want. I'm going to turn off my slope. Called the curve number generator. And what the curve number generator is it brings in multiple data sets and it calculates an erosion index called a curve number. And we're not so much interested in that maybe, but one of the layers that it brings in for you is a soils layer. And so it's a nice way to grab soils layers. And so that's what we're going to use it for. I've already installed it. And it is under, oh, where did it go? Oh yeah, it's going to be in my processing toolbox. They're not always. When you install plugins, sometimes they're under your menus, sometimes they're icons in a toolbar. Like these are all plugins that do very specific things. But this particular one installs in your toolbox. So here's my curve number generator. We're going to use the one for the continental United States because it uses NLCD data and Surgo soils data versus the ones for that you can have custom data you bring in or global data. All right. NLCD. So our area of interest, we can say it's going to be a vector. So you'll have to have a vector layer because it's you see how when I hit the drop down it only gives me this option for that field perimeter that I have. So it's only going to calculate my curve number for that field and bring in soils for that field. So you're going to have to make a vector layer or a field boundary, and I'll show you how to do that. I just realize that you'll have to have that in order to do the curve number. We don't have a table we're going to be looking up. We don't want to bring in the land cover. You already know what it is. We don't want to know about impervious surface. We do want to know soils. So we're going to hit the drop down and say save to file or temporary file. I don't care about calculating the curve number, so I'm going to say skip output. And then I'm going to run it. And it's going to return, that was really quick, it's going to return the soils for that polygon layer. I have that vector layer. And there's only one type of soil there, and it's, maybe there's two, but it's over here in this Surgo soil list, A. And you're like, well, what is A? We click on the attribute table, and we see that's Palouse silt loam 3 to 7%, or Palouse silt loam 7 to 25%. Okay, and it tells you all the characteristics about that soil too. Soils data is fraught with errors, but I mean, it's useful still. Okay, so let me show you one more thing. So say you had a big field. So say your field. Let's turn off aspect. That's the wrong one. Say your field was, I don't know, like this whole area right here. You come in and you say you want to create a new layer. Okay, and shapefile is fine. There's also something called a geo package if you want to store all your layers in one folder. I recommend a geo package, but just go ahead and work with the shapefile. So you're going to save it into your folder that you created, yada, yada, yada. I'm just going to save it into my downloads because I'm going to delete it. So I'm going to say field mask. And it's going to be a polygon. And I'm going to set it to the same coordinate reference system as the rest of my layers. If you need to search for it, you can search for it right here. Okay. I'm not going to worry about the fields because I'm just going to, you could actually add attributes that you're recording, like the name of the field, the farmer, or whatever. I can talk to you about that later. But right now I just want to draw it. So I have this field mask layer. I turn on the editing. This is my editing toolbar. Okay, anyway, I'm not gonna worry about that. It's probably my internet. So then you want to add a polygon, and then it's just going to be, maybe this is your field. Left click, and this, if you want to draw real field boundaries from data that you collect in the field, because you talked about that, we'll talk about how to do that in a different session. But this is just to get the soils data. We need a polygon, just a general polygon. You can make it bigger than the area just to get, whatever. Okay, one. And so there's my polygon. And so now when I go back in to calculate the curve number, I can say use the field mask. Give me my soils. I don't care about the curve number. And then I see same soils. But then I have the soils for that bigger area too. Okay. I think I might be missing something in this video, but or maybe I covered too much. Just let me know. Yeah. Okay. And of course, when you go to run through this and you run into if you run into issues, we can do a Zoom meeting or a Teams meeting, or you can just head over to my office and we'll run through it again. No problem. Okay. Thanks for being patient with me. And now I need to see if I can turn this